Hi everyone, this is Advanced Statistics for the Social Sciences. In this lecture, I'll show an example of multiple regression with the smoking cessation data. So this is the same example that we used in the simple linear regression video lectures. So let's revisit this study. So now we're going to add an additional predictor to this study. We actually, in this study, collected additional predictors, but now we're going to identify an additional predictor of interest. So in this example, a researcher conducted a smoking cessation study, and they wanted to determine whether number of years smoking and daily stress, the additional predictor, would influence the number of cigarettes smoked following participant in a treatment study. So participants reported their smoking history and their stress levels prior to the start of the study, and then researchers recorded the number of cigarettes smoked during a 1-week period after 1 month in the treatment program. And this is what that data looked like. So years smoking is a measured predictor variable where subjects respond to a survey, and so we see that this is on a continuous scale and has a meaningful 0 point. It's a continuous predictor. Pre-treatment stress level is also a continuous predictor variable. It's on a scale from 1 to 10, so we're considering it to be relatively continuous. And then the outcome is the continuous outcome of number of cigarettes smoked per day in the last month. And this is our measure of smoking intensity. So let's take a look at this data in visual form. So this is what the three-dimensional scatter plot for this data would look like. We can see that the y-axis is number of cigarettes smoked, and then we have the x-axis extending in either direction for years of smoking and for stress. Now, with a three-dimensional scatter plot, it's very hard to determine what, if any, relation among variables there might be. So it's a lot nicer for us to look at a scatter plot with a regression plane kind of superimposed onto the data. So this is what that plot would look like if we include the regression plane or regression surface. And also now we can see that there are error lines included that show us the distance between each point and the regression plane. So I've highlighted that here. So the regression plane now runs through the data points, and the green vertical lines are the leftover error between any given point and the plane. The green indicates that that point falls above the plane, and then those red vertical lines are the leftover error for points that fall below the plane. Now, the two models that we will be comparing, the null hypothesis and alternative hypothesis models, are that there is essentially no relation between either of the predictors and the outcome as the null model. And essentially we can see that what that would look like on a plot is that there would just be a flat surface for the regression plane. The regression plane would have no tilt to it whatsoever. And that's the plot on the left. And then our alternative hypothesis model is including both of the predictors in the model. So we must represent this in this three-dimensional scatter plot to have an axis for each predictor and one axis for the outcome. And the plane is no longer flat in this plot. We can see that it has some tilt to it towards either x-axis. So we, in order to describe this regression plane, we would have to include the predictors in the model. And this is all our alternative hypothesis model. So now we'll be fitting the regression analysis by incorporating both of the predictors into the model. So in SPSS, we do the process of fitting the regression model is the same as for fitting the simple linear regression. So in the drop-down menu, we go to regression and we select the linear option. And we get the pop-up window that we would get for simple linear regression as well. But the difference here now is that you can see that we actually have the option of putting multiple independent variables into the independence box. And so I've selected both of our predictors and I've put them into the box, and then I'm going to paste the syntax. So click the paste button after that. And that gives us this syntax window. And so the only difference between this SPSS syntax and the simple linear regression is that in the very last line, the subcommand method equals enter, both of the predictor variables are included, years, smoking, and stress. And that's the only difference between this code and the code for simple linear regression. So it's a very simple extension of the simple linear regression code, just including the additional predictor. So we won't go over the formulas for the intercept and slope estimates because they're obtained via matrix algebra expressions, and we won't be covering matrix algebra in this class. But they give results that are analogous to simple regression solutions. So we won't talk about the formulas. We'll just kind of look at the coefficients from the output and interpret them. But know that these regression coefficients define a surface that minimizes the sum of squared distances from the data to the surface, as indicated in the previous plot that showed those green and red error lines. And these are our least squares estimates. So this is what's important to us in interpreting the output from the multiple regression, is that essentially, as opposed to defining a line, a two-dimensional line, the regression coefficients are going to work together to define a surface, a three-dimensional surface. So this is what that SPSS output looks like. This is from the coefficients table. So we can see, and then I've also given you the regression equation that corresponds to this model. So we can see that the intercept is negative 7.62, and the year's smoking coefficient is positive 0.65, and the stress coefficient is positive 1.84. So let's talk about how we would interpret these coefficients. So now and we've talked about how the interpretations are slightly different from the interpretations from simple linear regression. So for the intercept from multiple regression, this negative 7.62 is now the predicted number of cigarettes for an individual with 0 years of smoking and with a 0 stress score. So a 0 score on stress. And we know just by looking at this number that it's a nonsensical estimate because no one is smoking negative 7.62 cigarettes. So this intercept doesn't really do much for us here, and we'll take a look at how we could get an interpretable intercept estimate later on. And then we also have slightly adjusted interpretations for the slope coefficients, and now we've got two. So the first slope coefficient, B1, is 0.65, and this is the regression coefficient relating years of smoking to number of cigarettes smoked. So we have to interpret this as holding the other predictor constant or controlling for the other predictor. So the new interpretation of this coefficient is that controlling for stress or holding stress constant, every additional year of smoking, the predictor of interest, increases number of cigarettes smoked by 0.65. And then for the B2 coefficient, it's a similar interpretation. So we're going to be controlling for the other predictor of years smoking. And this is the coefficient relating stress to number of cigarettes smoked. So controlling for years smoking or holding years smoking constant, a 1 point increase in the stress scale increases smoking by 1.84 cigarettes. So essentially, it's the same interpretation of a 1 point increase in X increases Y by this many units, but we're always controlling for or holding constant the other predictors. So if we had three predictors, it would be controlling for years smoking and the third predictor. A 1 point increase in stress increases smoking by 1.84 cigarettes. It's always controlling for whatever set of predictors there is. This concludes the second lecture on multiple regression. In the next lecture, I'll cover null hypothesis significance testing for multiple regression.